What can I help you with? I know some of you said there was something. Yeah, Enoch.
8.
Number 8? Was it the same one? 8, yeah, cool. All right. So let's take a look at number 8. So the nice thing when we're doing any of these, we always have Desmos at our disposal. So I'll do it the algebraic way, but if you don't feel comfortable doing that way, you can use, yeah. Yeah, Desmos is always available to you. I'm actually coming up with a quiz that'll be on Schoology. It's not done yet, but I will get it done. I don't know when I'll sign it, but it shouldn't be too bad. But the hard thing is coming up with sign lines on Schoology, you know, the F prime line, where I put in a line with numbers and then going plus, minus, plus. So I have to do a drawing of it on a drawing program, take a picture of it, but it's fine. It's good stuff. All right, so the very first thing they want to know about here on this problem are the roots. Okay, so we have to know that the roots are the original problem crossing x-axis. Okay, so that's the first thing we have to know. So, bless you. So what I can do is I can set the original problem equal to 0. Hello. Oh, I would have him third period, so I'm happy.
Okay.
Is that?
We brought a stray. I'm sorry.
Oh, cool.
I forgot
Yes.
to advisory day.
Oh, cool.
So I didn't know.
Cool. You can just set those chairs here and here. Thanks so much. Oh, you guys are awesome. Yeah, I'll get it to him third period. Is that cool? Okay, perfect. Yay, got a couple comfy chairs. All right. Thank you so much for doing that. Oh, and who came in? Caden, they found you. Glad they found you.
Yeah, no, I thought
He was under the chair.
He was under the chair. He picked up the chair. And he was listening.
Yeah, he was just he was like a turtle.
star.
Oh, hey Connor, did you have the homework?
I did not.
Okay. Caden, did you have the homework?
No.
And Andrew, I took care of you on the homework. So I appreciate you. Appreciate you looking out for me getting these. These look pretty good. I'm pretty happy with those. Good.
I like that one. That one's cool.
Oh, look at this. This will work out nicely for you. There's your desk. There's your chair.
There you go.
Look at that. Life is good. Oh, Sawyer. Sawyer, did you have the homework?
I do.
Yay. All right. Okay, so let's figure out the roots first. So I'm going to set this equal to 0. Of course, you could have used Desmos on it. I'll just do it regular. So between these, I can factor things that I have to realize is x to the 4th is this. Just showing the Algebra 1 approach. So this is how this problem technically could break down. So I could factor out x to the 3rd, and then I'm left with x minus 4. And it's still equal to 0. So I wind up getting x to the 3rd equals 0. So this means x has to equal 0. And then I have x minus 4 equals 0, so x is equal to 4. So right now, if on a graph, I know I have here and I have here. I know those are my roots. That's what that very first part of the question is saying. Now, I'm not sure which Algebra 2 class you had taken. I know that in the accelerated Algebra 2, if you had this and it was to an odd power, this creates something called a wiggle. And this was raised to the 1st, so this is where it crosses. If it was raised to an even power, it creates a bounce. So this is what a wiggle looks like. Probably looks something like this. Actually, it goes the other way. I drew it the wrong way. So that's basically what the graph could look like. Okay, the wiggle takes place because you have a variable equals 0, but that variable is raised to the 3rd power. If this is raised to the 3rd, the 5th, the 7th, some odd thing, it creates a wiggle, which technically becomes a point of inflection. All right. So is that okay for the first part? Okay. Then we want to do an F prime chart. So they want us to do an F prime chart. So what I'm going to do is I'm going to take the derivative. So I'm going to go F prime at x. And I know that I have 4x to the third minus 12x to the second. Okay. So check to see if we could factor this. It does appear that I could factor a 4x squared out of both. And that would leave me x minus 3. So if we set those equal to 0, this is how I'm going to find my critical values. And if you recall, my critical values become my turning points. So max min point of inflection. So this is going to give me x equals 0 and x equals 3 just by setting those equal to. So if my F prime chart is going to look like this. So I have 0 here and I have 3 here. So things that I could do to verify it would work. And this becomes a tough skill to figure out. Okay? If I look down here at this very base, or even I've looked at the original, it doesn't really matter which one I look at, but I'll take the base. If I were to take, say, a negative 10, which is far out this way. If I plug negative 10 in, this becomes a positive number. If I plug negative 10 in here, this becomes a negative. So a negative times a positive is a negative. So I'm going to get negative here. And then I'm going to find a value in between 0 and 3. So let's pick 1. 1 somewhere between 0 and 3. So 4 times 1 to the second, it's a positive number. 1 minus 3 is a negative number. Positive times negative is negative. So if I have the same exact two signs in a row, that means we must have a point of inflection. Very good. That point of inflection is that wiggle. Okay? All right, and then if I pick a value to the right of 3, so let's, I don't know, pick 10. 4 times 10 squared, positive number. 10 minus 3, positive number. Positive times positive is positive. So I go from a negative slope, so this looks like your negative slope, to a positive slope. So where do my fingers meet? At a min or a max? Min. Okay? So this is going to tell us that we have a min here and a point of inflection, call it POY, there. Okay? Intervals increasing. Ooh, intervals while increasing. So increasing means the slope is positive. So it's increasing here. It's increasing from 3 to infinity. Okay? Meaning it's going to continue to grow up there. Yeah.
For the F chart, I'm confused why you didn't use 0 and 4 from the graph.
Okay, so 0 and 4 from the graph are the roots. And then I take the derivative and I set that equal to 0, and that becomes my turning points. Meaning it could find me where a maximum takes place, a minimum takes place, or a point of inflection takes place. So this would be, if I had a graph like this, up here would be a maximum. If I had a graph like this, that would be the minimum. Those are the points I'm finding. But if I had like a value that does this, it kind of does this weird snaky looking thing, that becomes a point of inflection. Okay, so any three of those items could take place when you're dealing with it. So when you do your F prime chart, you're looking just where you have your derivative, whether it's factored version or not, where it's positive or negative. Okay, and that's where when we look at F prime, to the left of 0, we have negative. Between 0 and 3, we also have negative. That verifies there's a point of inflection that's taking place. Now, if you took Calc 1 next year in college, you could also find that could be a vertical asymptote in that situation, but we're not too worried about it at this point.
So you should always do the derivative of the equation.
Do the derivative, set the derivative equal to 0, and that will find you your critical values, which are your max, min, or point of inflection. And then when you create your sign chart or your F prime chart, the sign changes mean something. So if it goes from a positive slope, that would look like this, to a negative slope, that would create a max. If it goes from a negative slope to a positive slope, this would be a min. And if it was, if they were both negative, so like this and like this is a point of inflection that's taking place. So the slope itself, when I say slope, it means the basic meaning of slope from Algebra 1 is the same thing. Okay, it's the slope of the tangent line. So intervals where it's increasing 3 to infinity, where is it decreasing? Degreasing, I'm sorry. I think I did that yesterday too. Decreasing. Go away. Decreasing. Oh boy. I'm just going to start over. Decreasing. So it's decreasing. We have a negative slope to a positive, but it stayed negative. So it's decreasing from negative infinity because it stayed negative all the way through, all the way to 3. And then exactly at 3, that becomes a local min. Local min means that we're going to change direction going upward. And then max and min. Okay, or max slash min. So in this case, this right here, if I go from a negative slope to a positive slope, at 3, we have a min. Okay? So the strange thing is, so questions I think that students might have, especially with an introduction of some basic calculus, why can't we just always look at the graph and determine it? And the unfortunate thing is they don't always do it. They will sit there and say, hey, what would your graph look like based on this F prime chart? There's actually an F double prime chart that does take place as well, but we're not necessarily going to hit that. So there's just different things that do take place that they give you clues. So like they sit there and take more and more information away from you and say, hey, you only have this, therefore what does this look like? And so you kind of have to realize what's taking place with the F prime charts. There is an F chart as well. That's just telling you basically your roots and things like that. So did that help you on number 8? Number 8's got a lot of meat and potatoes to it. Okay. Any others I could talk to you about? We good? Happy? Everyone's content? Okay. So why don't I give you the opportunity to start on today's. So we're going to look at worksheet 5.2. You guys want a lot of homework tonight? Is it ever going to be yes? Oh, whatever. Okay. Why don't we look at worksheet 5.2, and why don't you try 1 through 3? And I'm happy to help you on any of those problems. Let me just mark down what I gave you. Today is what date? The 16th? Give you the opportunity to work on that. Happy to come around and help you. Yes.